All right, so we're going to begin the last a little section of our chapter P, which is all about rational expressions, right? So basically anything that's written as a fraction. All right. The first little bit of this rational expression section talks about domain. We actually don't go super in depth with domain in this chapter P section of it, but once we start chapter 1 and we solve rational equations, we'll talk a little bit more about what the domain of a rational function or a rational expression entails. All right, so essentially what we mean with domain is we just don't want, let's say I had something like 1 over x, we have a value that x cannot equal, right? And that just cannot equal 0. All right, so anything with a 0 in the bottom is considered undefined. Right, and you can verify it, right? If you graph in like a Desmos graphing calculator, like you can look up a Desmos graphing calculator and you type in 1 over x, you're gonna get like a weird shape, right? Which we're gonna graph at some point, right? It's gonna look like a weird little shape like this. But you'll notice at 0, there's not a value that it equals, right? There's no such value that if you plug in 0 for x, you're not gonna really get anything on the graph. All right. But again, we'll get more in depth about that much later on. But just to kind of introduce the idea now, just so that way when we get to it, you're not like totally lost on what we're talking about. All right, but we'll start with just regular simplifying fractions. Some of these look super easy and some of them you guys can very easily do, right? I don't doubt that you guys know how to do some of this already. But there's some examples that might require a little bit more work before you can simplify, right? So something super easy, right? Everything on the left-hand side of this cannot be simplified. I'm sorry, can be simplified. And everything on the right-hand side cannot be simplified, right? So these are some expressions that cannot be simplified. And we'll talk more about why in a second, but I'll just start with what can be simplified, right? So everything on the left-hand side of the slide can be simplified. 6 over 30, for example, a lot of you can do this very easily. You can cancel out a common factor of 6, and we get 1 over 5. All right? And that's just because they share common factors, right? So that's going to be the key thing in this lesson and in the future lessons, is that if there's a common factor, you can simplify it. Right, so 3x over xy, x and the x can cancel out, and we end up with 3 over y. Right, so this is something that can be simplified as well. Something like this can also be simplified, right? 2 times x plus y over 5 times x plus y. The x plus y and the x plus y are exactly the same on the top and the bottom, so they can be simplified. All right, same exact thing with the one underneath, right? We can switch the order of x and y, but it's still the exact same expression, right? Y plus x is the same as x plus y. And that's something that can still be canceled out on the top and on the bottom. And you're left with 2 over 5. All right. Now the next one's a little bit different. Might not look like it can be simplified, but it can. All right. So if you look at what we have on the top and on the bottom, it looks kind of the same. Now let's try to get it to look exactly the same. So I'm going to switch the order of the bottom, right? And let's see what happens there. If I change this, if I switch the order of the x and the y, I get a negative x plus y. And then notice there, when there's a negative in front, I had told you guys that's something that we're able to factor out. So this becomes x over y, that stays the same. If I factor out the negative on the bottom, I get a negative x minus y. All right. And then doing that, the x minus y and the x minus y cancel. And the only thing that you're left with is a negative. Now, of course, your answer is not just going to be negative. All right. That doesn't make sense. All right. But really, when you're dividing the same thing on the top and on the bottom, that's really just 1, right? Anything divided by itself is 1. And if there's negative, it would be a negative 1. All right. So our answer for this would be negative 1, right? They fully cancel out. All right. Now, these are examples that cannot be simplified. All right, so something like 3 plus x over xy, this x and this x cannot simplify. I know people do it every single time. Every single year I see people will try to cancel out these x's. All right, they cannot be simplified because there is a plus between this 3 and this x. Let's say it was something like 3x over xy, right? Something like 3x over xy, these x's now can be canceled out because they're factors. All right, so you can only cancel out factors but not terms, right? Remember, a term is anything separated by a plus or a minus, right? So 3 and x are terms here, all right? But x, y down here, these are factors because they're being multiplied. So this x is a factor, this x is a term, so they cannot be simplified. You would just leave it alone the way it's written. Can't do anything more to it. Another thing that you cannot simplify is something like this. Maybe you would think to try to do the same thing that we did in the previous example, all right, and maybe take out a negative, and maybe you want to make this a -2, all right? But what that's going to do is it's going to try and change the sign of everything in the parentheses. Now the y's match, but the x's don't, all right? So again, there's really nothing more that we can do to this. We would just leave it alone just like this. All right, so let's try some examples. Something like the first one should be super easy. All right, so 4 over 20, again, cancel out a common factor. They share a factor of 4, so I would divide the top and the bottom by 4, and I get 1 over 5. All right, very simple. That would be your only answer. All right, and you can do the exact same thing to something like number 2, right? These are factors on the top, x times y. Remember, a factor is anything that's being multiplied. And then w times y, these are both also factors. We are allowed to cancel out common factors. And the common factor here is a y. So I'm allowed to cancel out these y's, and I get x over w as the final answer. All right. Now you can take that same idea and apply it to number 3. All right, but notice, right, the idea that we just mentioned was that we can cancel out common factors. All right, now you might notice x and x are the same on the top and the bottom, but not both of them are factors, right? This x on top is a term because it has a plus in between. So I cannot cancel out those x's, right? That I cannot do that at all. So my answer would just stay exactly the same. I can't do anything to it. I would leave it alone just like that. All right, but something like number 4, hopefully we can see that this is different, because this is an x times x plus 1. And these x's now I can cancel because they're exactly the same on the top and on the bottom. This x right here that I just circled is a factor. This x right here that I just circled is not a factor. It's a term and separated by a plus. I can cancel out the factor but not the term. So we're only left with an x plus 1. All right, so we can do some more examples like these. They get a little bit more complex. I'll do 5 and 7 first because they're kind of similar. All right, so 5 and 7, we mix the numbers with the variables, but same idea. I would simplify the numbers. So 3 and the 6 have a common factor of 3, and I can make that a 1 over 2. Now x and x squared can simplify as well. There's 1x on the top and 2x's on the bottom. So we're just going to be left with 1x on the bottom, right? Think of it like x over x times x, right? You can cancel out a common x, and there's an x left over on the bottom. All right, we can try that same type of problem in number 7, right? So if you look at our numbers, 18 and 60, they share a common factor of 6. When I cancel out a 6, I'm left with a 3 on top and a 10 on the bottom, right? Divide them both by 6. Now, the x's, there's 2 on top, and there's 5 on the bottom. All right, so there's 2 and 2 that cancel. And you're left with 3 x's on the bottom, so I get x to the third on the bottom. Right. Another way that you could do it is you could do our rules of exponents. You could do x to the 2 minus 5 and get x to the negative 3 and then move it to the bottom, right? And it would still end up with an x to the third on the bottom, right? No matter how you choose to do it, some people can do that in their head, right? They can see that there's 2 on top, 5 on the bottom, so there's going to be 3 on the bottom, right? However you choose to do it is fine, as long as you cancel out the factors correctly, all right? Now, something like 6 and 8 are a little bit different in the sense that now it looks like, right, visually, it looks like they have nothing in common, and there's nothing that we can simplify, all right? But before we decide that it can't be simplified, you need to exhaust all of your possibilities. And it looks like we can try to factor these, right? So we just finished lessons on factoring. So let's try to apply that idea to these kinds of problems. If you look at the top, that is something that can be factored, right? X squared plus 4x minus 12 is just a regular trinomial that we can factor. We're finding what multiplies to negative 12 and adds to positive 4. So that's going to get me an x plus 6 and an x minus 2. All right, I can do the exact same thing on the bottom and try to factor that. 3x minus 6, I can take out a factor of 3, and I'm left with an x minus 2. And now you can see that they have things that match on the top and on the bottom. There's an x minus 2 and an x minus 2 that cancel out. So we're left with an x plus 6 over 3. And this would be our final answer, right? So we were allowed to cancel out these x minus 2's because they were common factors, right? Remember, factoring, we separate our polynomial into multiple factors. And so this entire thing, this x minus 2, this is a factor. It's being multiplied by other things. So we're allowed to cancel them out. All right, we can try the exact same thing with the one right underneath. All right, so we have trinomials on the top and on the bottom that we can try to factor. Again, you cannot cancel out terms, right? So a lot of people, every single year, people will cancel out x squared and x squared, right? But we cannot do that. There's pluses in between them, all right? So if they were factors, we could cancel them out. Because they are terms, we cannot. All right, so what we do instead is we try to factor the top and the bottom to see if they have any factors that match. All right, so on top, I'm looking for numbers that multiply to negative 20 and add to 8. That's going to get you a positive 10 and a negative 2. So I get x plus 10, x minus 2. And then on the bottom, I'm looking for factors of 10 that add to 11. That's going to be a positive 10, positive 1. All right, and it looks like the x plus 10 and the x plus 10 cancel out. All right, those are the same factors on the top and on the bottom, so we're left with an x minus 2 over x plus 1. All right, that's really the big idea that we're going for in this entire lesson, right? And I'm just going to do the exact same thing with the rest of these examples. All right, so number 9, we can look at something like this, and again, we can try to factor. All right, so the top, 4x plus 12, I can take out a factor of 4, and we're left with an x plus 3. And then on the bottom, I can try to factor that as well. We're looking for factors of negative 18 that add to negative 3. So that's going to get you an x minus 6 and an x plus 3. And then we can see that they have factors that match. All right, this x plus 3 is a factor on top and on the bottom. So we're left with a 4 over x minus 6. All right, nothing more we can do to that. That's our final answer. All right, so now let's look at number 10, right? The only way that these get harder is if you get harder things to factor, right? Maybe you have to do a couple steps before you can get to a fully factored expression. All right, but it's nothing we haven't done before. So let's look at the top. Something like this needs to be written in standard form first. So I would rearrange it so that the negative x squared is first, and then I have a plus x plus 12, and it looks like we can take out a negative 1 from it, right? As always, I like to take out the negative just so that our leading coefficient is positive. So it's going to be an x squared minus x minus 12, and then it looks like that is a little bit easier to factor on the top. All right, and it looks like the top can factor. We're looking for numbers that multiply to negative 12 that add to negative 1. All right, and that's going to be a negative 4 and a positive 3. So I get x minus 4, x plus 3, and then don't forget about the negative. And then so the top now is fully factored. Now let's try to factor the bottom. Remember, something like this is another trinomial, so we can do it kind of similarly, but we have to multiply 2 times 4 to get 8. And now I'm looking for 2 numbers that multiply to 8 that add to get me a negative 9. And it's going to be a negative 8 and a negative 1. So I get x minus 8, x minus 1. This one was different because there's a 2 in front, so I have to divide both of these by 2. Right? This is our slide and divide method. All right, and then x over 2 divides, so it's going to be x minus 4. And then 1 over 2 slides, right? I'm going to have to slide that 2 on the bottom out front. And this is going to get me a 2x minus 1. All right, and then now writing it like this, we can see that things cancel, right? I have an x minus 4 on the top and on the bottom. And that's the only thing that cancels. So I'm left with a negative x plus 3 over 2x minus 1. All right, nothing more we can do to that. That's our final answer. All right, let's try the same thing with the next one. Again, something that we want to try to factor. So I'm going to do first times the last, 3 times negative 2. I'm looking for factors of negative 6 that add to negative 1. And that's going to be a negative 3 and a positive 2. So I get x minus 3, x plus 2. But again, I have that 3 out front. I have to divide both of these by 3. So divide by 3, divide by 3. And then we slide and divide, right? 3 over 3 divides. That becomes x minus 1. And then 2 over 3 slides. I'm going to slide that 3 out front, and it's going to be a 3x plus 2. All right, so that's the top portion of it. The bottom I can factor by rearranging and taking out the negative. So I get a negative x squared minus 4x plus 5. And then I can take out that negative. So it's going to be a negative x squared plus 4x minus 5. Right? Just taking out the negative changes all the signs on the inside. And so inside we get a trinomial that we can factor. We're looking for factors of negative 5 that add to 4. And that's going to be an x plus 5 and an x minus 1. And now it looks like we have things that cancel out, right? X minus 1 and x minus 1 are the same on the top and on the bottom. And I'm left with a 3x plus 2 on top, a negative x plus 5 on the bottom. And we can leave our answer just like this. All right. Now doing the same thing for number 12, all right, might not be super apparent, but this is also another kind of problem that I would rearrange the top before I factor it, right? I want to make sure it's in standard form. And doing this is going to ensure that you can very easily see what the common factors are on the top and on the bottom. I think last year when I taught this lesson, I kind of taught you guys to look for opposite signs. Maybe there would be a negative that canceled out. But in this case, I'm just going to show you guys do it the exact same way that we've been doing all of the other ones. We're going to rewrite it in standard form and then take out a common factor like that. And so now that I write it as negative 4x plus 12, hopefully we can see that I can take out a negative 4 from everything. And when I take out the negative 4, I'm left with x minus 3. That does match on the top and on the bottom. So then I can cancel out the entire thing, and we're only left with that negative 4. All right, last 4 examples are going to work exactly the same way. All right, so nothing new here. It's just all sorts of factoring and then canceling. So number 13, it looks like on the top, I can factor that difference of squares. Square root the first, square root the second, one gets a plus, one gets a minus. So this becomes x plus 5, x minus 5. And then, of course, on the bottom, I would write it in standard form again. Negative x plus 5, and I can take out a negative 1. And then you're left with that x minus 5. And then this looks super apparent that there's the same thing on the top and on the bottom. And so we can write our answer as x plus 5 over negative 1. That's fine with me. Or another thing that you could do is you could multiply the entire thing by negative 1, and I can make this negative x plus 5. That's also fine with me. I think that looks a little bit better. Right, but dividing and multiplying by a negative 1 work exactly the same way. It just changes the sign of everything. All right. So let's keep going. We'll try the same thing with this one. Again, I like to write it in standard form, so it's going to be a negative x squared, or negative 8x squared plus 4x. And then we can take out a GCF. Right, our GCF on top is going to be a negative 4x. And we're left with an x minus 2. On the bottom, our GCF is going to be a 5. And I'm left with, oh, I did that wrong. Wow. Okay, that's very wrong. Okay. And then on the top, we're going to be left, 2x minus 1. Sorry. And then on the bottom, I can take out a 5, and then I'm left also with the 2x plus 1. All right, sorry about that. And now it looks like we have the same thing on the top and on the bottom, that 2x minus 1. So I'm left with a negative 4x over 5. Nothing more we can do to that. Nothing else cancels. That's our final answer. All right. 2 more just like that. Let's rearrange the numerator in number 15 just like we did a couple of times already, right? A lot of this is very repetitive. All right, and then when I do that on top, I can take out the negative, and then I get a negative x squared minus 3x plus 4. And then the top is going to factor. We're trying to find numbers that multiply to -4 and add. Wait, hang on. Okay, another thing I did wrong. Okay, that's going to be. Wow, okay. X squared, sorry guys, minus 3x minus 4. All right, is what's going to be on top. And you're looking for numbers that multiply to -4 and add to -3. Okay, we should be good now. So this is going to be a -4 and a +1. So x minus 4, x plus 1. All right, on the top. And then on the bottom, I have a 2 and a -4. I'm looking for numbers that multiply to -8 that add to -7. And that's going to get me a -8 and a +1. All right, so then I'm going to divide both of these by 2, right? When the leading coefficient is anything other than 1, you do want to divide by that number. All right, so then x minus 8 over 2 is x minus 4. And then x plus 1 over 2, I can slide that 2 up front. This is going to get me a 2x plus 1. All right, and so what matches is the x minus 4 on the top and on the bottom. This is going to get me a negative x plus 1 on top. And then on the bottom, a 2x plus 1. Nothing more we can do to that. That's our final answer. All right. And then lastly, number 16. All right. Same exact process as all the other ones. You're just going to factor and cancel out your common factors. All right. It looks like there's nothing super special about this one. It just looks like x squared minus 1 is a difference of squares. So it's going to be x plus 1, x minus 1. And then on the bottom, we have 4 terms, which we know 4 terms we factor by grouping, right? I can take out the x squared, and I'm left with an x plus 1. I can take out a plus 9, and I'm left with an x plus 1. All right, so then I'm left with an x squared plus 9 as one factor. And then our matching factor was x plus 1. All right, and then so from here, you can cancel out your common factors. And then on the top, you're left with an x minus 1. And then on the bottom, you have an x squared plus 9. All right, so that's it for this lesson. Hopefully shouldn't be too bad. It's just a whole bunch of factoring and canceling out. The next lesson should be pretty similar. It's a lot more factoring and canceling out, just with more bigger expressions, right? So multiplying, dividing is kind of similar. All right, so it shouldn't be too bad.